What if we detonated a nuclear bomb on the moon? Imagine, for a moment, the night sky as it's known around the world. The unwavering presence of the moon, its pale surface a geological register of billions of years. Unchanged by weather, almost untouched by human hands. For decades, the moon has fascinated humanity, not just as a geological body, but as a cultural, poetic, and symbolic anchor. But what if, in a singular act of science or demonstration, we detonated a nuclear bomb on the moon? This scenario, once considered not just by science fiction authors, but by military planners, raises deep questions about science, ethics, politics, and the fate of our nearest heavenly neighbor. Let's journey through the possible consequences, peeling back the layers of scientific, environmental, and societal impacts. To understand the potential outcome, it's essential first to grasp the scale of nuclear weapons and Earth's relationship with space. Since their inception in the 1940s, nuclear weapons have symbolized both the apex of destructive capability and a somber warning about the limits of human control. The most powerful bomb ever detonated, the Soviet Tsar Bomba, yielded more than 50 megatons of TNT, unleashing destructive energy far greater than all the explosives used in World War II combined. Yet, despite Earth's violent surface history with atomic blasts, the moon has never faced such a human-induced event. Let's begin at the moment before the hypothetical detonation. Suppose a spacecraft carrying a modern thermonuclear warhead approaches the moon. Its target, a chosen crater or designated location on the surface. The warhead is released, programmed to trigger either just above the lunar surface or on impact. There is no atmosphere here. On Earth, a nuclear blast creates a fireball, shockwave, and mushroom cloud largely because of the air. The moon's near-perfect vacuum, however, transforms the explosion dramatically. At the exact moment of detonation, the nuclear device releases an intense burst of energy, light, heat, radiation, neutrons, and a shower of fission products. This energy races outward in all directions, but without air, there's no blast wave, no deafening roar or air pressure wave. Instead, the explosion carves out an expanding sphere of incandescent vapor, pulverizing nearby rock and regolith. The surface at the epicenter vaporizes instantly, creating a crater of fresh, glassy melt. The shock energy transmits through the solid lunar crust, launching fragments, some catapulted kilometers, into the black sky. The mushroom cloud that defines nuclear explosions on Earth cannot form here. There is nothing to billow upwards, nothing to support the hot gases and debris. Instead, a rapidly expanding shell of vapor sweeps outward, momentarily lighting up the lunar night. For a few seconds, the glow could be visible from Earth through telescopes, an unnatural flash on the ancient face of the moon. But how large would the explosion be? The size of the new crater would depend on the bomb's yield and the composition of the local regolith. For a device similar to the Hiroshima bomb, about 15 kilotons, the resulting crater might be tens of meters across, dwarfed by the moon's natural craters, which reach hundreds of kilometers wide. A 100-megaton device could excavate a crater hundreds of meters across and several tens of meters deep. To Earth-based observers, this is still insignificantly small. Lunar impacts by asteroids routinely generate far larger scars. The moon's far side, for example, is dominated by the South Pole Aitken Basin, nearly 2,500 kilometers across. In geological terms, even the most massive nuclear detonation would be a pinprick. Nonetheless, such an event would not go unnoticed. Sensitive telescopes and lunar orbiters would detect the blast, the vaporized rock, the ejecta splashing outward. Some debris, unimpeded by air resistance, would enter lunar orbit. If ejected at more than 2.4 kilometers per second, the lunar escape velocity, it would shoot off into space, perhaps falling toward Earth as tiny radioactive grains, or joining the thousands of meteoroids and fragments orbiting the Sun. What about radiation? Earth's atmosphere and magnetic field provide a protective shelter, trapping radioactive fallout from nuclear tests and limiting their spread to the biosphere, oceans, and land. On the Moon, no such shield exists. The products of fission and fusion, radioactive isotopes would be dispersed directly into the vacuum. The intense neutron flux from detonation would irradiate nearby lunar soil, generating new radioactive elements. With no wind or liquid water, fallout would not settle and drift as on Earth, but simply remain near the blast site, gradually decaying over many years. Would the detonation harm the moon structurally? The short answer is no. Even the largest device ever conceived would be infinitesimal compared to the moon's bulk, a cosmic marble weighing over 7 trillion kilograms. However, the local environment would be irrevocably altered. At the blast epicenter, the surface would be rich in glassy beads and fused rock, unlike anywhere else on the moon, except perhaps the regions scarred by eons of meteorite impacts. Long after the explosion, astronauts visiting the site would find radiation levels higher than the background. The pristine regolith transformed by exposure to intense heat and neutron irradiation. Scientific instruments left nearby, such as seismometers, would register the blast as a sharp pulse, providing data about the moon's structure. But such a detonation is not merely an act of physics, it's an act entangled in history and politics. During the height of the Cold War, both the United States and the Soviet Union considered detonating nuclear devices on the moon, not as weapons but as demonstrations of technological might. Project A-119, a little-known U.S. Air Force plan, proposed a lunar explosion to display American dominance in space. It was canceled, partly out of fear of global backlash and practical ambiguities. Supposing the detonation occurred today, what would be the international response? The Outer Space Treaty of 1967, signed by virtually every spacefaring nation, explicitly forbids the placement of nuclear weapons in orbit or on celestial bodies and bans their use in outer space. This agreement grew from Cold War anxieties to protect space from militarization and preserve celestial bodies for peaceful exploration. Detonating a nuclear bomb on the moon would violate this treaty and spark global outrage. Even if billed as scientific, the act would raise ethical questions. What right does one nation or group have to scar the moon's surface, however slightly? To send radioactive material into space, potentially endangering lunar missions or contaminating the lunar environment? The symbolic impact, damaging the moon everyone sees, could foster public horror and reignite old debates about the militarization of space. From the perspective of science, the data from a lunar nuclear detonation could in theory be valuable. The shockwaves produced could give insight into the moon's internal structure, similar to how seismologists once used nuclear tests to probe Earth's crust. The chemistry of post-blast regolith would reveal how moon dust responds to intense heat and radiation, yielding clues about natural impact processes. Yet, today, with seismic sensors, radar, and robotic probes, we've developed far less destructive methods to study the same phenomena. What about astronomical impact? Could the blast produce enough light to be seen unaided from Earth? For even the largest device, the flash would be visible for only a second or two as a small pinpoint. Only sensitive telescopes turned to the right place at the right time would catch the event in detail. For most, the moon would appear unchanged, its cycles and face unaltered, except perhaps for a tiny new dark spot, discernible only by lunar orbiters or with high-powered lenses. There would be no long-term increase in lunar brightness, no persistent change to the moon's reflectivity, no broken moon. Could such an event have environmental consequences on Earth? The risk is, honestly, very low. Lunar gravity is weak, and any radioactive material ejected sufficiently to escape the moon would be dispersed across the vastness of space. Only a minuscule fraction might eventually enter Earth's atmosphere, where it would likely burn up. The overwhelming majority of the radioactive debris would stay on the moon, inert and decaying atop a barren surface, far from Earth's biosphere. Yet the psychological and cultural impacts could be profound. Across history, the moon has been a constant, witness to the rise and fall of civilizations woven into myth and memory. The act of detonating a nuclear bomb on its surface would mark a new era. The first time humanity, as a species, visibly and deliberately altered a celestial body with nuclear force. For some, it might symbolize scientific prowess or the capacity to shape new worlds. For others, it would represent a violation, an unnecessary, irreversible act of hubris, echoing the environmental scars left by nuclear testing on Earth. Could there be planetary-scale risks that are not immediately obvious? While science assures us that there is virtually no chance of shifting the moon's orbit or trajectory, some postulate about dust clouds thrown into temporary lunar orbit, perhaps affecting future landings. With the moon hosting more and more missions, from robotic scouts to planned permanent bases, local contamination from even a single nuclear detonation could complicate landings, missions, or settlement plans for years to come. Finally, the hypotheticals carry a message about the future. If humanity is to become a true spacefaring species, how will we regard the bodies of our solar system? As blank canvases for technological demonstration? Or as shared heritage to be protected and explored with humility and foresight? The detonation of a nuclear weapon on the moon is, in the end, as much a moral question as a scientific or technological one. Let's recap. Anchoring this thought experiment back in the present. A nuclear blast on the moon would create a new crater, alter the regolith in a small region, and temporarily release radioactive material locally and into space. There would be no global threat to Earth, no visible destruction of the moon as a whole. The night sky would look the same to all but the most determined telescopic observers. The scientific yield, while allowing some unique data, would come at the cost of violating treaties, sparking controversy, and perhaps forever altering our relationship with our celestial neighbor. If there is a lesson in this scenario, it is not just in what science can do, but in asking deeper questions about what it should do. Every action in space, especially those carrying the legacy of human conflict, reverberates through history, culture, and the collective future. The moon, silent and watching, beckons us not only to explore, but to consider the impact of every footprint, every blast, and every decision as we venture beyond our home. Thank you for watching the video. What do you think about today's topic? Feel free to share your thoughts in the comments below. If you enjoyed it, don't forget to like and share the video to support the channel. Thanks again, and see you in the next video.